Right, a very standard differentiation question and a question about tangents here. So, first of all, we have to write out an expression for what dy dx is. So dy dx is 3x squared plus 10x. That's our equation. We'll probably get a mark for that. We bung in x equals -1 into here, so 3 lots of -1 squared plus 10 lots of -1. That's 3 lots of 1 plus 10 lots of -1. So that gives us -7. So we've shown that, so we can say quod erat demonstrandum, which means which we write QED for. Right, in the next stage, work out the equation of the tangent of the curve. So the equation of a tangent is going to have the same gradients. Some students have been saying to me that it will have a perpendicular gradient, but that's the normal that we'll be looking at there, not the tangent. It's the same gradient, and it's going to go y equals mx plus c. Now the gradient is from here, so don't forget that gradient is dy dx. And for an explanation of that, remember that gradient we measure by doing rise over run. So this is the rise, dy, the change in the y coordinate, and this is the run, the change in the x coordinate, the change in how far along we are. Now, we've only got one bit of this so far. We've got y equals -7x plus c. Remember the m in y equals mx plus c is the gradient. So we need something else to find out the rest. Right, well we've got x equals -1. We could do with the value of y, and then we could work out what c was. Now this equation here tells us what y is. So we bring in x equals -1 into that. So y equals -1 cubed plus 5 lots of -1 squared plus 1. So that's -1 plus 5 plus 1. So that's 5. So we've got a value of x and a value of y there. So we bring in the value of y into our equation of our tangent. So that's 5 equals -7 lots of -1 plus c. So that's 5 equals 7 plus c. So that means c is -2. Now, we've got our m from our equation from before, that was given to us, the -7. We've got our value of c, so our equation of our tangent is y equals -7x. Take away